Lecture on Atomic Structure. Introduction. Welcome to today's lecture on atomic structure. Atoms are the basic building blocks of matter, and understanding their structure is crucial to understanding chemical reactions. In this lecture, we will discuss the subatomic particles that make up an atom, their properties, and the models used to describe atomic structure. Subatomic particles. The three subatomic particles that make up an atom are protons, neutrons, and electrons. Protons and neutrons are located in the nucleus, which is the central part of the atom, while electrons orbit the nucleus in shells or energy levels. Protons have a positive charge and a mass of approximately 1 atomic mass unit, a mol, while neutrons have no charge and a mass of approximately 1 atomic mass unit. Electrons have a negative charge and a negligible mass compared to protons and neutrons. For example, the atomic structure of carbon-12 can be represented as follows. 1. 6 protons, positive charge. 2. 6 neutrons, no charge. 3. 6 electrons, negative charge. Atomic number and mass number. The atomic number of an element is equal to the number of protons in the nucleus of an atom of that element. For example, carbon has an atomic number of 6, which means it has 6 protons in its nucleus. The mass number of an atom is the sum of its protons and neutrons. For example, carbon-12 has 6 protons and 6 neutrons, so its mass number is 12. Isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. For example, carbon-12 and carbon-14 are both isotopes of carbon, but carbon-12 has 6 neutrons and carbon-14 has 8 neutrons. Isotopes have the same number of protons, so they have the same atomic number and belong to the same element. However, they have different mass numbers and may have different properties. For example, carbon-14 is a radioactive isotope that is used in carbon dating to determine the age of organic materials. Electron configuration. Electron configuration is the arrangement of electrons in the shells or energy levels of an atom. The first shell can hold up to 2 electrons, while the second and third shells can hold up to 8 electrons each. The electron configuration of an atom can be represented using the Aufbau principle, which states that electrons fill the lowest energy orbitals first. The Pauli exclusion principle states that no 2 electrons in an atom can have the same set of quantum numbers, and Hund's rule states that electrons will occupy empty orbitals before pairing up in the same orbital. For example, the electron configuration of carbon can be represented as follows. 1. 2 electrons in the first shell. 2. 4 electrons in the second shell. Atomic models. There have been several atomic models proposed over time, including the Thomson model, the Rutherford model, and the Bohr model. The Thomson model proposed that the atom was a positively charged sphere with electrons embedded in it, while the Rutherford model proposed that the atom had a small, dense, positively charged nucleus with electrons orbiting around it. The Bohr model was an improvement on the Rutherford model and proposed that electrons orbit the nucleus in discrete energy levels, and that electrons can only occupy certain energy levels. The Bohr model was later replaced by the quantum mechanical model, which describes electrons in terms of probability clouds rather than fixed orbits. For example, the quantum mechanical model predicts that electrons exist in regions of space called orbitals, which are described by a set of quantum numbers. The most commonly used quantum numbers are n, principal quantum number, l, azimuthal quantum number, m, magnetic quantum number, and s, spin quantum number. The principal quantum number, n, describes the energy level of an electron and can have integer values from 1 to infinity. The higher the value of n, the higher the energy level and the farther the electron is from the nucleus. The azimuthal quantum number, L, describes the shape of the electron's orbital and can have integer values from 0 to n1. The value of L determines the subshell that the electron is in, with L equals 0 representing the s subshell, L equals 1 representing the p subshell, L equals 2 representing the d subshell, and L equals 3 representing the f subshell. The magnetic quantum number, m, describes the orientation of the electron's orbital in space and can have integer values from L to L. Each subshell can hold a maximum number of electrons, with the s subshell holding 2 electrons, the p subshell holding 6 electrons, the d subshell holding 10 electrons, and the f subshell holding 14 electrons. The spin quantum number, s, describes the spin of the electron and can have values of +1/2 or -1/2. The Pauli exclusion principle states that no two electrons in an atom can have the same set of quantum numbers, which means that each orbital can hold a maximum of 2 electrons with opposite spins. Conclusion. In conclusion, the structure of an atom is composed of subatomic particles including protons, neutrons, and electrons. Understanding their properties, behavior, and arrangement within an atom is essential to our understanding of chemical reactions. We learned about the different models used to describe atomic structure including the Thomson model, Rutherford model, Bohr model, and quantum mechanical model. Finally, we explored the concept of electron configuration using the Aufbau principle, Pauli exclusion principle, and Hund's rule and the quantum numbers used to describe the arrangement of electrons in an atom.